Okay, the second IE for any element is always higher than the first IE. They say which of the following is correct. So yep, from X gas to X2 plus gas. All right. Okay, so as you keep removing electron from a certain element, it becomes more and more positively charged, right? So once it becomes more and more positively charged, it's actually going to be more difficult to remove the electron. So the second IE definitely will be higher than the first IE. All right, so this is definitely correct, true. All right, the ionic size for sodium plus is the same as Al3 plus because they are isoelectronic. Even though they're isoelectronic, they have the same number of electrons. Al3 plus has 10, sodium plus has 10. But you realize that aluminum actually has more protons. Okay, more protons, right? So because there's more protons, the 10 electrons are attracted more closely to the nucleus. Is Al3 plus is supposed to be smaller. All right, so it's not actually the same. So this is false, wrong. Okay, the removal of 2 electrons from chromium to form Cr2 plus is from the 3D. Now, when you remove electron, you always remove from the 4s first. All right, but for chromium, since chromium is 3d5 4s1, so if you want to form Cr2 plus, you need to take from the one from the 4s and one from the 3d. But they say that removal of 2 electrons is from just the 3d, which is wrong. Okay, so this is actually false. Okay, let's do option number 4. So in fact, aluminum, all right, it will become Al plus, okay, then become Al2 plus, then become Al3 plus, and become Al4 plus. Okay, all right. So for silicon, okay, silicon is from Si, yes, right, silicon plus, right, then silicon 2 plus, silicon 3 plus, all right, then silicon 4 plus. Okay, the thing is this, if you look at the configuration, in fact, this guy, aluminum 3 plus, has a noble gas configuration. That's right. So the configuration for actually Al3 plus is just like 2, 8. Okay, I'm keeping it simple. But the configuration for Si3 plus is actually 2, 8, 1. All right. So you realize that from here to here, all right, to remove one electron from Al3 plus to Al4 plus, you're removing from the second shell. Okay. But from Si3 plus to Si4 plus, all right, you're actually removing electron from the third shell. Okay. So because you remove a third shell, it's actually further from nucleus, all right, much further from nucleus. So it's definitely much easier, okay? So which means this one has a very high fourth IE, okay? So very, very high fourth IE. So aluminum atom would actually require more energy. So which means this is actually true.